Earth systems. The atmosphere. What are convection currents? When liquids and gases are heated, the particles gain energy and begin to move more. This causes them to take up more space, so the fluid becomes less dense. The hot fluid rises, while colder, more dense fluid sinks. This sets up a convection current. In the Earth systems topic, you will find that convection currents happen in both the geosphere, atmosphere, and hydrosphere. The atmosphere. Composition of the atmosphere. The atmosphere is made of layers of gases held in place by the Earth's gravitational pull. 78% is nitrogen and 21% oxygen. The carbon cycle. Carbon is an important element that is part of all living things. It passes from organism to organism and cycles through the world in a number of processes. Photosynthesis. This takes CO2 from the atmosphere and turns it into the plant itself. Eaten. Plants are eaten by animals, which are in turn eaten by animals passing on the carbon atoms, respiration. All living things use oxygen in food to release energy and CO2, which returns to the atmosphere. Decomposition. When waste is produced or organisms die, decomposers will break them down and release the nutrients and CO2 fossil fuels. Millions of years ago, living organisms died, and over time they changed into coal, oil, and gas, which all contain the carbon which they were made of. Combustion. Burning of any organic product releases CO2 into the atmosphere. Convection. Currents in the atmosphere. All our weather systems, both globally and on a local scale, are driven by convection currents within the atmosphere. Just as with the oceans, the atmosphere near the equator is warmer than that nearer the poles. When air is heated, it will rise, and cooler air will come in to replace it. This sets up convection currents, which we observe as the trade winds and other global weather patterns. On a smaller scale at the coast, the land surface will heat up and cool down more quickly than the sea. In the morning, the land heats more quickly than the sea. This causes an onshore breeze to develop. In the evening, the land cools more quickly than the sea, and this causes an offshore breeze to develop.